Hello, geometry students. This is Mr. Bear, and I'm going to bring you Skill 7.1, which will be all about translations. Okay? So, over the course of these next few lessons, we're going to be talking about transformations. And what a transformation is it's a movement that allows you to move one object to another. And so there's going to be four main ones that we look at. We're going to start with translations. So let's start with describing the similarities and differences between these two triangles. All right, so if we look here, if we were to look at some of the similarities, one of the things we might notice is that both of these triangles are the same size and the same shape. So we might know that those are the same size and shape, but they're just located in different spots. And when this happens, we say that the figure was translated. Okay. So important word here. All right. So now let's look at how to do a translation. So first of all, when we do a translation, we're moving all of the points of a figure the exact same way. So if we look at this triangle ABC as we see it plotted, we're going to move that triangle so we take every point left 4 units. So I'll start here at A and I'm going to go left 4 units, plot that point. And because those points are corresponding points, I'm going to call this A apostrophe, which is also known as A prime. And I'm going to, whoops, I shouldn't have plotted that yet. Sorry. Sorry, because I forgot about moving it up 2. So my apologies. Let's go back and do that again. So starting here at A, I'm going to go left 4 and up 2. That's where I'm going to call it A prime. And I'm going to do the exact same thing for points B and C. So point B, I go left 4 and up 2, call that B prime. And for point C, we're going to go left 4 and up 2, and here's C prime. And we connect the dots, and we have a triangle that was translated. We could describe this as a rule. We would say that our coordinates x comma y become, you take your x values, and when you go left 4, you're subtracting 4. And when you go up 2, you're taking your y coordinates and you're adding 2. So we can use that notation to help us be able to find the coordinates. All right, so now let's list what they are. So A prime now has the ordered pair -6, 5. Or I'm sorry, that's -5, 5. It's hard to see those numbers. B prime, if we look here, we went -1, 8. And for C prime, we have, looks like -2, -2. And it says, describe what happened to the measures of the 3 angles and the 3 sides. Well, if we look here, it doesn't really take a whole lot to kind of notice that the angles stayed the same. Or I should say angles stay the same. I actually kind of want to say corresponding angles. All right, I'm just going to rewrite this. Sorry, friends. So corresponding angles are congruent. And then also notice that corresponding side lengths are also congruent. This means that translations are a rigid transformation. Okay? And all that means is when you do the transformation, the new figure is congruent to the original figure. So if the angles stay the same and the side lengths stay the same, when you do your transformation, that means that you have a rigid transformation. Okay? All right, if we look at the next one here, it says, what is the shortest possible way you could explain to someone how to get the top quadrilateral to move to its newest position? Okay, so we're going to take this point here and we're going to map it to this point here. So we're going to see how far over we went and how far down we went. It looks like we went 1, 2, 3, 4, 5, 6 to the right, so that's a +6. And then we went down 1, 2, 3, 4, so -4. So you move every point, right 6, and down 4. So we could say that x comma y maps or becomes x plus 6, and it's x plus 6 because we're moving in the x direction 6 units to the right, and then y minus 4 because we're taking our y values and we're going down 4. Now as a vector, you could write this as 6 comma -4, where the 6 and the -4 are those numbers there. And so you might see vector notation as well. Okay. And if you were to check that with other points, I'll just do that really quickly. Let's see, if we look from here to here, we went 1, 2, 3, 4, 5, 6 to the right, and we went 1, 2, 3, 4 down. All of those points should move the same way, so that shows that that is in fact our translation. All right, so some key ideas. First thing that you need to know is that translations preserve lengths and angles. And that's what makes it a rigid motion. Okay? So they are congruent. Okay? Second thing you need to know is that to get a translation rule, what you do is you say x comma y goes to x plus or minus some number, comma y plus or minus some number. Okay? And so just to kind of remind you what those pieces mean, remember this is the original point. This means becomes. This is your horizontal movement. And this is your vertical movement. Okay? And then just remember that every point moves the same way. Okay? So that's what you need to know about translations. So let's do a couple practice problems here. Here I've got a polygon bread, B-R-E-A-D, and we are told that we need to find the coordinates of the new polygon B prime, R prime, E prime, A prime, D prime by doing this motion here. So x plus 7, so that plus 7 means go right 7, and the minus 5 means go left, or sorry, down 5. Okay, so let's go ahead and plot these. So our point B right now is -4, 4. So B prime is going to be -4 plus 7, 4 minus 5, which gives us 3 comma -1. go ahead and write these down. Point R is originally at -1, 7, so we're going to have -1 plus 7 and 7 minus 5, which gives us the coordinates 6, 2. For E, originally E was at 3, 5, so we're going to take 3 plus 7 and then 5 minus 5. So I'm just taking the X and the Y coordinate from the E point, and I'm applying the rule to it, so we're going to get 10, 0. A was originally at 2, 1, so we have 2 plus 7 and 1 minus 5, which gives us 9, -4. And then finally for D prime, D is at -2, -1, so we go -2 plus 7 and -1 minus 5, which gives us 5, -6. So those are going to be the new points for the new figure once it's translated. Okay. For the next one, it says write the rule that takes ABC to its image A prime, B prime, C prime, or explain why it cannot be done. Okay, if we look at this first one, this is not a translation. And it's not a translation because all points did not move the same amount. Okay. Now on part B, we can see, oh, this point matches with this point, and so we went over and down, so we went 1, 2, 3, 4, 5 over, so we have X plus 5. Oh, whoops, I didn't see that the apostrophes were on the upper one. Okay, let's go back and backtrack that, sorry. It's hard to see on this, but we're actually going from the bottom triangle to the top triangle, so we actually need to count the other way. So it looks like to get from the bottom dot to the top dot, actually it might be helpful if I map this out horizontally first. So we're going to go left. We're going to go left 6 units, so it'll be X minus 6. And then we're going to go up 1, 2, 3, 4, 5. We're going to go up 5. So we'd say X comma Y becomes X minus 6, Y plus 5. Okay? Alright, for the last one, it says quadrilateral FISH fish has coordinates of what you see here. And then it's translated so that H prime is 3, -7. So imagine H, which had the H had the ordered pair -2, -3, and now it becomes H prime is 3, -7. So we're going to have to think about this a little bit differently. Think about what did we do to the -2 to make that become a 3. So if we think about that, 3 minus -2 equals 5. So we added 5. And then what did I do to the -3 to make it become -7? Well, you take -7 minus -3, which gives you -4. So we subtracted 4. So the rule then becomes xy becomes x plus 5, y minus 4. So now we find f prime, I prime, and s prime. So for f prime, let's see, f was -8. When I add 5 to that, I get -3. 11 minus 4 is 7. For I prime, I had the ordered pair -7, 9, so -7 plus 5 makes -2. and 9 minus 4 gives us 5. And then for s was 0, 6. 0 plus 5 is 5. 6 minus 4 is 2. And that's going to be our coordinates for the new values.